Good morning, everyone. You are the bold, the brave, the fearless. Thank you for being here at this really beautiful time in the morning. I got a notification on my phone that said flash flood warning until 8:45 a.m. I was like, word. Cool, 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 cool. But anyways, if you are coming in, please, please, please do come closer, just because as we do fill up and people get here for the start of the day, we want to make sure it's easier for people to have access to seats. So please come closer. Come closer.
Yeah, you get more credits. I should ask Marietta to add it in the ice cream challenge that like maybe if you move at the front, maybe sit at the first two rows, you get extra point or something like that.
It is it's an honor-based system, so we believe in you. So anyways, want to take it away?
Yeah, sure. So first, we have our first lightning talk speakers telling us how to dine with $0. Thank you.
Good morning, y'all. Thank you. I know it's early. I don't normally get up this early either. My name is Austin Williams, and today I want to talk a little bit about me, the problem I'm solving, the goal I have, and hopefully the future we can solve using Python. So the main takeaway, I want you to know that if you know anyone who might benefit from anything I have to say, please take a picture of the very last slide. I will make it evident that it is the very last slide. This entire presentation will not take 5 minutes, I promise you. So a little bit about me. After completing my undergrad last year in Florida, I decided to pursue a PhD in material science at Carnegie Mellon. Don't know why I did that. No, I'm kidding. I love it here. But I love food as well. And in that pursuit, I decided to maybe develop a little bit of a project to help me cook food and deliver food to myself, essentially. I'm saying all this to say that I am not a programmer or a developer, but I was able to make a little project. So after switching to a gluten-free diet in January of this year, I noticed that my food options became very limited. Eating out is expensive and food waste is prevalent. Some, but not all restaurants accommodate according to your dietary restrictions and preferences, and who's trying to eat out every day anyway. So I figured, how can I use what I already have at home? How can I use the groceries and cooking equipment and utensils I already have at home to make something delicious and quickly? And Python is the answer. So the goal here is to use, or the problem with the original applications is that they require tedious ingredient inputs. What that means is you have to scan every single item, and I feel like that's just taking the grocery store and putting it within my home. I don't want to do that. And I also want to provide accurate portions per meal. So considering I want to have essentially no leftovers in a warm meal every single time, ideally. So the goal here is to develop an application that scans grocery items and cooking equipment quickly while providing personalized meal plans that accommodate for your schedule, dietary needs, and budget. And a bonus, we can partner with local food rescue shelters that can deliver free food that has nothing wrong with it to your house. And we can also present instructional animations to make cooking less intimidating and maybe even a little fun. And so when I first thought about this, I looked up something and I found YOLO V8. I found RoboFlow. And I put it all together and I made a little bit of a prototype. So I have an extremely early prototype that's been built. I was told not to do a live demo on stage, so I won't start here today, but please come find me afterwards. And I need help speeding and scaling up the system, and I think this is definitely the room to do it. So I'm looking to get this product out to the world, either as open source or whatever is the best way possible, as soon as possible, but we need developers like yourself to make it happen. Let's not waste time or food. And thank you to my CTO GitHub Copilot. So here's the last slide, as promised. Please take a picture of this slide if you know anyone who can benefit from anything I said. I'm looking for developers, artists, and foodies. And the QR code to your left, there is a survey. It only takes less than a minute to complete. And if you fill that out, you might win $100. The first 100 people will be entered to a raffle, and they get to win $100. Thank you.
I like food too. Actually, this city has quite a lot of really good food. So if you see me like roaming around and I'm like rubbing my tummy, be like, I know a great place to eat. So please do that. So our next speaker, before actually we go to our next speaker, just a reminder, each lightning talk is 5 minutes. When we have about 30 seconds left in that 5 minutes, we'll start doing the little finger tap. So please, if you see one of your MCs doing that, please join us so we can help cue our speakers to know that they are getting up to the time that they are allotted. But our next speaker, Yong, is going to be telling us a really, really cool bit about their journey into data science.
All right, hello everyone. Before I start, is there any foreigners or any university students out there? All right, good seeing you. Let's begin. I have only 2 slides, so it's gonna like boom. All right, my name is Yong Lim, which means glory to God. I'm an undergraduate student from South Korea, studying library science and big data. And this is my first time attending PyCon US, and today I want to share my journey in data science, especially from intensive learning environments and how I ended up being here. So I started my data science journey 4 years ago with a passion for analyzing data to solve real world problems. While studying library science was enjoyable, I felt a bit stronger pull towards the data. So early on, I realized the importance of guidance, so I actively sought out for a good mentor. One thing about Korean students is that we often supplement our school learning without outside sources. So it gets aggressive sometimes, but when we feel our school education isn't enough, there are increasing opportunities for us to network outside of school, and there are tons of boot camps popping up every day, small hackathons to bigger data analytics competitions. So that's how I kept my study going. Everything was big fun, like Pandas, Scikit-learn, Seaborn, or TensorFlow. But not just technologies, I want to mention that it was the people to me. I brought myself here because my mentor, Joy Park, she's like right over there. She's going to speak later. And my cousin is here also because I brought him here. And guess what? He's going to bring all the PyCon US back to Samsung where he works at when we get back to Korea next week. So it's very small connection that makes the community all bigger. And once you find a good mentor, the next thing, then it's time to move on to making a greater team. Find members nearby, although it could sometimes be stressful. And after several boot camps, I moved on to making practical projects, small businesses with my fellow colleagues called UniRun. You can check it right here, and my colleagues are right there. So this thing, it's a running application for university students using blockchain's tokens, and I'm still working on it, and it's going to be my graduate project coming this August. And one more thing to consider as a student is a learning environment. I love how Python users are so into Python, and Python users in Korea are so open to one another. We often do a called mo kakko, which means coding individually but together at one place, such as school cafeterias. So it's a great way for students who want to step outside the traditional learning environment and get together, form teams, and even share knowledge. So I hope the culture of sharing experiences and knowledge continues to grow in Korea, where we help and support each other, just like here in PyCon US. And lastly, I wish for a broader global recognition for Korea. Although Korea is not an English-speaking country, I try to bridge this gap by running a YouTube channel. It's here, right here, the QR code. Where is it? YouTube channel where I teach Korean to foreigners. Feel free to check it out, and feel free to check my LinkedIn also. And that's it for today. Thank you.
Yeah, thank you so much. And I'm always happy to see young people how to bring initiative and be the leader of our future. So thank you so much. Next, talking about young people, how we can kind of already start teaching our kids when they were very, very young. There are abilities that we won't be able to learn when we get older. I've heard that if you don't learn other languages when you're young, you won't get the same ability to learn them when you're an adult. So our next speaker, Paul, is going to tell us how to teach children perfect pitch. Thank you.
Thanks. Hi, good morning. I'm Paul Ganssle, and today I'd like to talk to you about my application that uses a chord identification method to help children acquire absolute pitch. Okay, so if you don't know, absolute pitch or perfect pitch is basically the ability to hear a note and know what it is without reference to another pitch. Most people have what's called relative pitch, where we can only tell if one note is higher than another note, but not what it is on an absolute sense. So you can't just hear it and say, oh, that's middle C. My understanding is that people with absolute pitch experience sound the way most of us experience color. So if you had like relative color, the way you have relative pitch, you couldn't look at an object and determine that it's red, right? You'd just be able to know if it's more or less red than another object. Now, I always thought it would be cool to have perfect pitch, but I had been under the impression that it was not something you could learn, right? Either your brain processes sound this way or it doesn't. But then I came across this paper from 2012 claiming that with enough training, it's actually possible to acquire perfect pitch in childhood. It comes from a school in Japan called the Ichiyonkai Music School, and they claim to have a 90% success rate using their method to train children between the ages of 2 and 6. And conveniently, they give you the method in the paper. Now, there are some reasons to be skeptical of these claims, right? For one thing, after the advent of the reproducibility crisis, which I strongly suggest you look up if you don't already know about it, we should probably be pretty skeptical of any studies, especially ones that are not pre-registered and they're coming from a music school that sells you books teaching you how to do this method. To me, though, the fishiest part about this study was the dropout rate, because as you can see, as you'll soon see, the method involves quizzing 2 to 6-year-olds 5 times a day for several years. And I imagine anyone who has tried to get a 2 to 6-year-old to do anything even once will find this extremely suspicious. But they seem to think that it's that 90% of their participants had perfect adherence to the protocol. So I don't know. I think there's at least some very strong selection effects happening there. That said, I don't think there's a ton of real research in this, and it wasn't a huge time commitment. It's distributed in an annoying way, but at the end of the day, I think it was going to be a bonding experience. So, what's the method? Okay. Basically, it works by taking a number of chords and you associate them with colored flags. You introduce the chords to the child one at a time, and you quiz them on it until they can identify them with 100% accuracy. And once they can do that, you introduce a new chord, but you don't introduce new chords in an interval any shorter than 2 weeks. And the sessions are 25 identifications per session, and you do them 5 times a day. When the child has mastered all the chords, they can start scaling back to like 1 a week, as long as they can maintain like 100% accuracy. You do it until they're 9. Okay, so now you know the method, and presumably you have a piano you can play, and you can generate random sequences of chords in your head. Oh, and remember, we're doing this 5 times a day. So hopefully your piano is very portable, or you don't want to get too far away from your house. Yeah, obviously we're not going to do any of that, right? But this is exactly the kind of thing that being a programmer is all about. Obviously, I built an app. I threw together this web page. It's on GitHub. It's a static site. There's no backend. It's all HTML, JavaScript, and CSS, and it's permissively licensed. You can fork it and have your own version of it up and running in 20 minutes. And here's what it looks like. It's pretty simple. It displays the chords you're on. It'll play one randomly, and you pick which one you think it is. If you get it right, the kitty is happy. If you get one wrong, the kitty is sad. And when the child starts mastering the chords, you move on to the next level. You add more and more. There are 9 white key chords, and once they master all of those, you enter the black key phase, where they stop calling out colors and they start calling out chord names. So they'll say C, E, G instead of red. And then there's also this mode, which is like trainer mode, so you can actually introduce the chords one at a time or work on individual chords that the child might be having trouble with. Okay, let's see it in action.
They can see the kitty getting sad. Now, Max, can you deliberately get a couple wrong? I want to show them what happens when you get them wrong, so they can see the kitty getting sad.
Okay, so that's my talk. Here's a link to the application. We could use more users. We could use documentation, and code contributions. All welcome. And I'll be in the hallway to talk about this if you're interested. Thank you.
That was really adorable. I think those were cat ears. So I like that. Anyways, our next speaker, I think, is going to be taking us on a scavenger hunt, if I am not misremembering. And I'm going to go ahead and now pass it over to Roisin to take it away.
Thank you very much. Hi, everyone. I am Roisin O'Dowd. I'm a Pittsburgh local and also a software engineer, and I'm here today to take you on a scavenger hunt that I took my friends on back in 2020. So to set the scene, think of April 2020. The world was shutting down, coronavirus was becoming more rampant, and my roommate and I were both software engineers, basically trapped in our apartment trying to come up with things to do outside of work. So we decided that when we were not getting our friends together in person, we were going to challenge them on a technical scavenger hunt, maybe torture them in order to have some of our friends meet each other and so on. So we created a Discord server and we made this whole project and basically like strong-armed our friends into doing it. Not everyone was technical, so the clues were a mix of things like poems, ciphers, and also stenography. The abilities really surprised us. So for example, some software engineers who came up with a string of 10 numbers could not think to type it into Google, versus some of our non-coders immediately recognized that the 412 was actually a Pittsburgh area code and they called the number. So to give an example of some of the clues that we had, I'd like to introduce you, if you haven't already known about it, to stenography, which is the practice of concealing information within another message or some piece of digital or physical media. So here you may have an image that at first glance looks very normal, but if you zoom in, you see that there's some pixels that look dead on the left. And if you open this up in a simple text editor, you can see that I just went into WordPad and wrote a clue. So this was, I think it was the first clue, maybe it was the second clue of our scavenger hunt. And what the users would have to do is, once they found this clue, it would contain some sort of password or a riddle to a password, which they would type into what we had was a PHP server set up to accept passwords and serve up the next clue. So for an example of something more complex where we were hiding a message in an image, you have this beautiful image here of data servers, which is in the bitmap format, so it is not subject to the same sort of lossy compression as other image formats. It's quite large, actually, as a file. If you look at the image in WordPad or something, you can see that there's no plain text hidden here. So we were using a concept here of hiding an image in the least significant bits. So if you're processing an image, at least in the form of a bitmap, there are 3 channels, red, green, and blue. Each of them is represented by a byte. Here on the screen, you can kind of get a visual representation where each pixel is represented by an object that looks kind of like this. And same as our ordinal numbers, binary numbers also have bits that are more significant and least significant. So if you change the bit that is 256, you're going to see that your image has changed from red to blue or something. But if you change the 2 place, you're not going to necessarily notice this. So for example, we're hiding an image in these like least significant bits. So what we were doing with the code to encrypt and then decrypt was the user would be seeing a certain portion of the image, and then the possible hidden image would be hidden in those least significant bits. So here we have just like a very simple sample decoding the least significant bits algorithm where you're iterating through the pixel map generated by the bitmap, and then you can pick out each red, green, and blue byte, bit shift it, and also perform an AND operation to mask the most significant bits here. We're using the Python image library, and for the sake of time, this is a very simple example, but it can get more complex, of course. This is the decoded image here, so once you run it through, you have something that gives you a password, And this is a more complex stenography one that we also used. Thanks for your time. If you have any questions, let me know. Thanks.
Yeah, that's very impressive because I am a little bit into the gaming thing, and I now know that like people now hit high messages in their game, so people can play a game in real life. So it's kind of mind blown. So that would be one of the techniques that they could use. That's really smart. Next, so we always deal with numbers, and sometimes I was like, I'm very bad with like counting things because sometimes I lose count. But our next speaker is going to teach us how to count to 1023. So thank you so much.
Morning, everybody. So I don't know if anyone out here has children, but we teach children to count, starting off with fingers. There's a number of limitations with this approach. First of all, we're teaching them base 10. Also, when we start to teach them addition and subtraction, it's great for a linear scale. But I want to propose a new approach, which is to teach children binary from the beginning. We can do this by basically using a 10-bit encoding, one for each digit, which is your finger. So you can count to 1023 just by having 10 fingers up like this. For anyone who's not familiar with binary, we'll just do a bit of basic counting. So this is an interactive one. If you can hold up both hands, we're going to count together. So 1, 2, 3. We're going to stop there. So, for example, 21 would be these 3 digits. Now, that's great for numbers, but when we teach children the alphabet as well, we can use the 7-bit encoding from the ASCII standard. A lot of the terminal operators are probably not particularly useful for kindergarten. Now, this is great, but there's a number of limitations with this. And I've given an example here using the ordinal function to get the number for the letter A, which we can then encode. But if I get the number for A in hiragana, which is one of the Japanese alphabets, that number does not fit on my fingers. So when teaching this method to Japanese students, we've got a number of limitations. So what I proposed instead, in requiring 14 fingers, is that we look at the hiragana code block, and then what we can do is assign, because with UTF-8, we have 8 fingers available, but we've got 2 spare. So what I was proposing is that we use the 9th as a bit flag to shift the encoding up to the Japanese code blocks, which does not include kanji, so this would only work for hiragana and katakana, and also fixed width punctuation, which is useful for proper grammar. So with this UTF-9 encoding, we have the first flag. I also want to propose using flag 2, potentially for Hangul, so we can use this for Korean, but we can maybe develop that in later years. So this is all quite hard to do by hand. So obviously we would use Python to do this, and we could do this by implementing a codec. You can inherit from the codec class to implement your own codec in Python, and all you would take as an input is a string. This is Python 3, so it's already Unicode, and then the result is a string of bytes. So we're basically looking for the 9th finger as a flag, and if that exists, we do a shift upwards. Then we have a decode method where we receive the other way around, which is the string of bytes, and then we look for that flag, and if we get it, then we can encode back. So for example, I've got hello Tokyo, so hello Tokyo, and the output can then be encoded backwards and forwards. All of this is extremely practical and useful, also very easy to teach to children. We can also teach them left shift as a great way of learning their times tables. So yeah, I would like to propose this as a standard going forwards. On a more practical note, I would like to highlight that we have a tendency, I say we as developers, and particularly English-speaking developers, have a tendency to forget or put the needs of other languages secondary to English. And I'd like to highlight this blog post I wrote a while ago, which is talking about OpenAI in particular, and OpenAI encodings and how they behave with Chinese, Japanese, and Korean, and how a number of tools have actually forgotten that those scripts exist, or they just either don't work or they work extremely poorly. So there's definitely a lot we can do to improve that going forward. And if you're interested, actually they just last week hugely improved this. So GPT-4o is a massive step forward on this. Yeah, thank you for being here.
I found myself trying to count on my fingers. I went like this. I was like, 6? It's that time in the morning. Anyways, our next speaker, Eric, is going to tell you something that you should try out. So let's go ahead and take it away with Eric.
Hi, all. So I've been working on Subinterpreters for a while. My name's Eric Snow. I work for Microsoft on the Faster C Python team. And I'll tell you a little of the story here. In 2012, I became a core developer, and in 2014, had an experience that really galvanized kind of my desire to do something about Python's multi-core story, which everyone complains about the GIL. I want people to stop complaining about the GIL. So I started something. I didn't have a lot of technical background, but I figured I'd figure it out, and mostly I have. So I've given talks about this subject, about subinterpreters, in 2019, 2023, and there have been other talks about this stuff, and there are 2 really exciting talks that you should go see this year. One by Anthony Shaw and one by Yuri Silivanov. So in 2023, I had a PEP 684 about making the GIL per interpreter. So if you have subinterpreters and you have each has its own GIL, then each one can run independently in different threads without sharing a GIL, and suddenly you get multi-core processing with Python. There's some limitations because it's just a different concurrency model, so it's not free threading like you think of it, but I don't know, I think it works better for the human brain anyway. So at my talk last year, I talked about this and how it landed in Python 3.12 and how everyone should love it, and then I also promised that I'd get a package out on PyPI that explained, or that let people try it out with their Python code, which is kind of the point of PEP 734, is a PEP about adding a standard library module to do this. So that didn't happen. I didn't get a PyPI module up. And PEP 734 isn't going to happen in Python 3.13 like I'd hoped it would. So instead, what we're going to do is I'm putting up a package on PyPI. I just published it like 10 minutes ago. And so you can try it out. There's not a whole lot to it. It's Python 3.13 though, so you'll have to use Python 3.13 for now. I hope to backport the stuff to 3.12 so it's a little more accessible. But it'll give you a chance to try out the feature, try out the really basic API I have there. But what I'm most excited about is that it's going to be an opportunity for the community to take this foundation that we've set and build on it, come up with some really cool, amazing stuff. And so I know that it's kind of a beginning of a really exciting time. I was going to publish right now here during the talk, but I chickened out. But here's the page. You can see I just released it. And that's it. So go try it out.
Yeah, thank you so much. It looks like a really good thing, good feature that you should try it out. I would say that I have a lot of friends in the Python community, as you can tell. And a lot of my friends have something very, we have a common thing, which we have a background in physics. So I don't know, I think is it an overlap with like, the physics community and the Python community? Or is it like because, job in physics doesn't pay well, so people like, learn Python and become a developer and get a better job? But our next speaker, I don't know his background, but he's going to tell us about using Python to discover physics. So thank you.
Thank you. I'm Jake Stevens-Haas. I'm a PhD researcher at University of Washington, hopefully finishing soon. And my research is in how to discover differential equations from data. And as part of that, I maintain the package that the lab uses and some other labs around the world, the Python for the sparse identification of nonlinear dynamics. And if you don't love math as much as I do, it's only 5 minutes. I am sorry. But this is also a talk about the open source development of this library. So why would we go about doing this? Well, I met a person the other day who had a lot of neuron data, voltages across neurons in the brain, and part of the stuff they're looking at is how those neurons connect and affect each other in terms of firing patterns. There's people with concentration data of chemical species in a metabolic process, for example, or people who are trying to control a plasma. There's a whole host of different time series data out there that this is useful for. And if I could take a step back, it is 2024, and we have neural nets that do time series modeling very well. We even have physics-informed ones, neural ODEs and whatnot. But I would submit to you that on the other end of the explainability spectrum are the actual equations of motion for these kinds of systems. And ever since the time of Newton and Leibniz, what it meant to understand a system was to know the equations. And those 400 years have been great in the math field for developing more math, for developing tools for understanding the equations. We have things like local stability guarantees for control theory. We have things like weak differential equations, implicit differential equations, even Lyapunov functions for bounding and guaranteeing the global stability of the discovered model. And pysindy does a lot of that. So when it works very well. And these are just some pretty visuals from some of the papers. You don't need to know this. And I'd be selling it too hard if I said it worked out of the box. And it does if you have a simple system and you have high quality, you have low noise, and you have high resolution data. But the process of discovering differential equations often starts with a differentiation method, synonymous with smoothing, depending on how your data is measured. You have different options in the package, and there are people who have, including myself, who have researched these different options. You also have to suggest terms that might be in the differential equations, polynomial terms, sinusoids, partial derivatives, and whatnot. And then you also have to choose, or use the default method, for how you want to pick out which terms are in your differential equation. There's options for strictly limiting the number of terms. There's options for guaranteeing global stability of the modes, etc. And I got involved with this project because I am a fiend for really difficult pull requests that require reading papers. But I think this is I'm interested in both the math and the coding side of things, and it is a really interesting problem to figure out how your API and your type and class system can prevent the kinds of nonsensical math combinations that we allow. And part of the reason for that is this evolved out of the lab when people wanted to compare their methods for science. It tends to cater to the right here, which are people that published very rapidly in the 5 years after this, or 7 years after the original paper came out, their own versions of this. And not all of them are a part of pysindy, and there's a lot of work that we're doing to refactor it, to make it more usable, and to include a lot of these methods for science. But there's also people with actual data, and we're trying to make the package more amenable to people that just don't want to do the math and have the data. And I would ask, if you do have data, try it out. And in open source, we love. If it doesn't work, submit a GitHub issue and talk through it with me. Or if you want to work on it, we do have a bunch of good first issues. Thank you for your time. If you want to talk more about it, I'm hosting an open space at 2 o'clock in room 308 on research engineering. Thank you.
Fantastic. Oop, hello. Okay, great. Awesome. Now we're going to have a fantastic person. Shameless plug, PyLadies. If you have not gone to the booth, please, please, please go to the booth. Get a cool shirt like the one I'm wearing. If you don't have a ticket for the fantastic PyLadies auction, just know you should definitely get a ticket next year. But I'm going to go ahead and pass it off to Lynn, who's going to take us on a fun, fun adventure.
All right, thank you. I also just want to thank Lorena and Chuck for hosting lightning talks. I had this job not too long ago, and I know how hard it is to wake up in the morning. All right, so Lynn Root here, and I'm here to save your code base. So have you ever walked up to a new code base or a library all ready to use it? You know, you cracked your knuckles, got to solving your big code problems, but then you come to find out that nothing is documented. Have you ever, and you never wish that you found the otherwise wonderful looking tool. And has this ever happened to someone? Maybe not just me, yeah, thank you. Or, yeah, it kind of sucks. Or how about this? Maybe you've been inspired to contribute to your favorite project. You have a feature that you want, and you have the time and the energy and the skills to add it. What a perfect and rare combination. So you pull up to the code base, only to find that your superhero maintainer does not document anything. Has this happened to you too? Maybe? Yeah? Thank you. It's so disappointing, right? Or, you know, maybe you are a maintainer of a library and you have put a lot of work into documenting everything. You've set up your code base to be the most approachable for contributors and users as possible. You deserve a gold star. And you've got a pull request. Maybe it's for that new feature that folks have been wanting. What a great day. But they didn't document a damn thing. The nerve of them. So it's not that great of a day. Anyone else have this happen to them too? Yeah? Is it just me? Okay. It's a very tough world out there, no doc strings anywhere. So how is a stick person supposed to be productive? Don't worry, my friend. I have solved this problem for you. I've had these exact same problems way too many times, so I've made a tool called Interrogate. You just pip install Interrogate, and off you go. Off you go. So it's a tool much like coverage for measuring test coverage. You run interrogate command on your project, and you'll see just how much docstring coverage there is. You can run it with increased verbosity to get more details, and even more verbosity to actually see the objects that are covered or missed. But wait, there's more. By simply adding the generate badge flag, you can show off how high quality code your code base is with your very own badge. Wow. I am not done yet. Let's not forget to add interrogate to your talks.any file to enforce a level of code coverage, or documentation coverage. So no longer do you need to be that annoying stickler to those oh-so-nice contributors and colleagues who have submitted undocumented code. Or maybe you prefer to use it in your pre-commit setup. That's cool too. Folks have already found it so useful that they've contributed a GitHub action and a VS Code extension to make your dev workflow even more pleasant. Talk about more bang for your buck, eh? Oh, and the best part of it all is it's got its very own super cute, very pink sloth logo. Aww. So the next time that you find yourself struggling with the absence of doc strings, enforce people to explain themselves with a friendly pink sloth. Make your life easier and start interrogating today with pip install interrogate. Thank you.
I think we need a sticker with that cute sloth face on it.
I forgot to bring them.
Oh, so there is actually stickers. Okay, well, I will keep an eye out for that one. So we are going to have that as our last speaker for this morning. Please do hang out. We just need to get the stage set up for our diversity and inclusion panel, which is going to be amazing. So please, please, please stay, hang out, learn about the awesome work that the PSF Dine group is doing. Any other notes for what's going to be happening with future lightning talks?
Yeah, so future lightning talks, we will have the board, just like what we said yesterday, that keep signing up, and then we would choose lightning talk, and please pay attention to your email. We will notify you. If you don't respond to us, then we will assume that you don't want to give the talk anymore. So anything else?
Well, what happened Sunday morning?
Sunday morning, yeah, I'm still accepting more conference organizers to send in their one page of slides to kind of announce their event. So keep emailing in.
Fantastic. Well, we appreciate you all being here bright and early with us. Again, let's give a huge round of applause to this morning's speakers, and we'll continue at 9 o'clock.